This will be our Test 1 review for intermediate algebra. So if we look at the first question, 4p minus 3 equals 21. We want to undo the minus 3 first. We will add 3 to both sides. That cancels. We get 4p equals 24. We'll divide both sides by 4. And we get p equals 6. We'll circle it, and then we'll put our answer in the answer box. Your test will have answer boxes on it. You will need to put your answers in the answer box. You'll need to use pencils only, no pens. Second question, we want to distribute the 3 first. There's nothing to do inside the parenthesis on either one, so we don't have p from PEMDAS. There's no exponent, so we go to multiply, which is, in this case, a distribution. So 6x minus 6 plus 9 on the left-hand side, right? That's not 6x minus 6. Let me fix that. 6x minus what? 3. That is correct. Now when I put these together, I get 6x. And when I have negative 3 and plus 9, I get plus 6. And now I can no longer do anything to the left-hand side. On the right-hand side, I'm going to take this negative 2. I like to circle it, distribute. 7's out front. Negative 2 times 5 is negative 10. Negative 2 times negative 2x is plus 4x. Then I put my 7 minus 10 together, get negative 3 plus 4x. And now it doesn't matter what you move, but I'm going to move the 4x, but you can move something else. I'm going to subtract 4x from both sides. I think we did something different in class, but that's okay. So I'm also going to then subtract 6 so that the numbers, the x is canceled on the right, numbers cancel on the left. We get 2x equals, and that's negative 9. 2 negatives we add together stays negative. Then we divide by 2, and we get x equals negative 9/2. And that is my final answer. For the next one, again, this thing starts at the same line as that was there. So we pick something to move. So I'm going to move the 8m, but it doesn't matter. You can put the 6m to the other side. That cancels. I'm also going to cancel the 11 by subtracting it from both sides. That way I have m's canceling on the right, numbers canceling on the left are constants, and I have negative 2m equals negative 32. Right here we add these together and keep it negative because they are both negative. All right. Then we divide by our coefficient of m, that's negative 2 right here. We divide by that, and whatever we do to one side, we do to the other. This divides out, becomes m equals, what's a negative over a negative? It's positive. So that's going to be positive 32 over 2 is 16. So our answer there is 16. Then here we are going to need a common denominator. My LCD for the problem is going to be, well, let's see, we start with the biggest one, 12. Does 2 go into 12? Yep, 6 times. What about 3? 4 times. 4, 3 times. So they all divide into 12. So then my LCD is exactly 12. All right. So then I take 12 times my first term, 12 times my next term, and then equals 12 times 3/4 x minus 12 times 1/12. And I want you to notice my fractions. This would extend out and cut my x, and so would that one. If it doesn't, remember it's too low. If you use slanted fractions here, you will almost assuredly use them incorrectly on the 1/2 x and the 3/4 x. And if it's used incorrectly, Mr. Guess will count off. 12 is really over 1, so I'm going to remind myself of that on all the fractions. Here, this becomes a 6. 12 divided by 2 is 6. This 12 divided by this 2 is 6. So then 6 times 1 times x is 6x, and then minus this 12 over 3 becomes a 4. So this becomes times 4. Those are multiplied. That gives me 16 equals 12 over 4 becomes a 3. That's a 1. And again, everything in the denominator is becoming a 1, so we have no fractions left. That's the whole point. We multiply that together and we get what? 9x. And then we take those 12s, divide out, and we have a bunch of 1s left, and that's minus 1 because there's a negative sign there. Now it doesn't matter what you move. I'm going to move my 9x. And if I do that, that cancels. I also want to move my negative 16. That's going to cancel on the left. So I get negative 3x equals positive 15. Then I divide both sides by my coefficient of x, which is negative 3, and I get x equals negative 5. I get x equals negative 5. For the absolute value of w equals 364, remember for absolute value, if it's equal to a positive, it can equal the positive of that number, or it can equal the negative of that number, right? So we typically write that plus or minus when it's the same number with a plus sign or a negative sign. So plus or minus 364 for that one. And then here, absolute value equals a negative. So remember, this is positive or 0, and that equals a negative. When does a positive equal a negative? Never. It never happens. When does a 0 equal a negative? Never happens. So if this never happens, this is no solution. No solution. I'll even take ain't going to happen. There's no solution. Now on the next one, the high five here, this is the absolute value of 3x minus 4. Here it is, absolute value. But then you have this before you get to the equal sign, right? We need to get rid of this and put it on the other side. We want this all by itself and then equals. So let's go ahead and try that. Let's look here. This is going to be subtract 4 from both sides. That cancels. We get 3x minus 4 in absolute value. We haven't taken care of that yet. Equals 15 minus 4 is 11. Now, absolute value equals a positive number. Check. We keep going, right? That means we have two equations, right? Two equations. So what are my two equations? Well, one of them is 3x minus 4 equals 11, or 3x minus 4 equals what? Negative 11. Remember, we never, ever, ever change what's in here. Put it here and put it here. Do not ever change it. Never change it. Absolute value. What changes is the equal sign changes around, but an equals backwards is still equals. And the 11 changes to a negative 11. So then we solve each one of these. We're going to add 4. And this is something you should just do and look up and say, oh, Mr. Guest, you got it right. Divide by 3, we get x is equal to 5. Over here we add 4, but this time we don't get 15. We get 3x equals negative 7, right? Negative 11, positive 4, different signs. 11 minus 4 is 7. 11 is larger. Keep it negative because 11 is negative, and then divide by 3, so x is equal to negative 7/3. So x equals 5 and negative 7/3. If I wrote it outside, I'd circle it, but I really want my answers in here, right? I already have x equals. Don't write that. 5, comma, negative 7/3. Remember, as we go through this, you can pause it, rewind it, that kind of thing. So if I move too fast, let me finish a problem or get to the end of something, and then you can pause it and pick it back up. So here, there's no absolute value here, so this is simply solve it. Just subtract 9, just like you were solving an equation, 2x. Don't forget this is less than right here. And it's going to start this. 2x is less than 13 minus 9 is 4. Then what do? We divide both sides by 2, and we get x is less than 2. There is no and, there is no or, there is no sandwich here, because this did not have absolute value bars. So we just keep going. We care about 2. Less than is to the left. If you note, if you put x on the left side, this thing points this way, so then we shade this way. It points to where it shades if you put the variable on the left. I didn't say you had to do that. Don't tell somebody next semester because you'd be telling them a story. All right. So then what goes around the 2? A parenthesis, and we got negative infinity, comma 2. Parenthesis here. What always goes around negative infinity? A parenthesis. The reason we start with negative infinity here is because it was the leftmost thing here. As we move across, here's the first thing we have shaded. What does that represent? That. That's why that goes first. Then we end the shading. That's why this goes last. So then we have 4x minus 11 greater than or equal to 13. So we're going to take and add 11 to both sides. 4x is greater than or equal to 24. We're going to divide by 4. So x is greater than or equal to 6. Because 24 divided by 4 is 6. So we care about 6 on our number line. We're going to shade to the right because greater than is to the right. And also x is over here and it points to the right. So we're going to shade to the right. So then this is a bracket around 6. So we have 6 comma infinity, because as we move across here, the first thing we have shaded is 6. The last thing we have shaded is infinity. So this is going to be a bracket around 6, and infinity always gets a parenthesis. Always. I didn't mark that. Let me mark that on the end of my arrow here. I usually write that. This represents infinity. That's why I put infinity here. Remember, this is on the end. It has to be to the right side here. This is out here at the end. It needs to be on the far end here. Whatever you get to first comes first. Whatever you get to last comes last in interval notation from left to right. On this one, we have the absolute value bars. So that means we need to look at it. This is greater than. This is great or. This is a great or. Great or. I know greater spelled ER, but remember that dorky math teacher thing, great or. So then x minus 3 greater than 8. Or, here's your or. Never change x minus 3. X minus 3 is less than negative 8. If you recall, I said we turn equals around, which stays equals. Well, if we turn a greater than around, right, it becomes, if it was greater than, it becomes less than. So now we add 3. We get x is greater than 11. Over here we add 3. And we get x is less than negative 5. So we care about two numbers here. Negative 5 and 11. X is greater than 11. It's going to be here and go to the right. That's this arrow, which represents infinity, and it gets a parenthesis. There's no equals here, right? No equals in this means parenthesis. We always open our parentheses towards our shading. We would not do this because our shading is over here, okay? So then negative 5, less than negative 5 is going to be out here to the left. So this time we have negative infinity by this arrow. And which way is our shading? It's out here. So what do? We open our parenthesis up towards our shading. All right. So interval notation is going to start with negative infinity, comma, negative 5. Then we're going to have 11, comma, infinity. And if you recall, infinity and negative infinity always get parentheses. And then we have a parenthesis on negative 5 and on 11 both. And then we have the U without the tail or without the kickstand. You go down and back up. You do not come back down. It is not the letter U. It is a union symbol. The letter U is incorrect. Again, on the mailbox here, we have absolute value bars. This time it is less than, which means let us make a what? A sandwich. And if we make a sandwich, 2y minus 9, this part's in the middle, right? And we make a sandwich this way. Both of these things point the same way as this. Right? And we say negative 13 on the left and 13 on the right. Remember, this one is like an and I told you that every and in math can be done simpler in here with this kind of logic, this and or business. The ands can be written this way. This is like the two stripes in the highway. You live between the two stripes because you live less than so many miles from the point in the road that we're talking about. So here we're going to add 9 to all three places, both sides and the middle. We can't say both sides because we have a middle here, right? We have three parts. So this is negative 4 less than or equal to 2y less than or equal to 22. Then we divide all three pieces or parts by 2. So we get negative 2 less than or equal to y less than or equal to 11. All right? So then we have two numbers on our number line we care about. It doesn't matter what order they are right here. What matters are which one's smaller. Negative 2 is smaller than 11, so it must go to the left. Here's 11. It's to the right of negative 2 on the number line. Where are we shaded? In the middle, between them. They both have equals on them, so they both get brackets. Notice here we didn't shade this arrow nor this arrow, which means we don't have what? This is negative infinity. This is positive infinity. We do not shade them. We didn't, so we don't write infinity or negative infinity in my interval notation. I start at negative 2. I go to 11, and both of them have brackets on them because of the equal sign. Both have brackets because of the equals sign. And then now we get over here to these. Remember, x-intercept, the y is 0. For the y-intercept, the x is 0. You can get that right without doing anything else. So remember, if x is 0, I'm sorry, for the x-intercept, I said it wrong. If y is 0, this term is gone, right? So I really have 5x equals negative 15. So I'm dividing what? Negative 15 divided by this thing here, 5, right? So what is negative 15 divided by 5? It's negative 3. So negative 3 comma 0 is your x-intercept. For your y-intercept, I let x equal 0. That's gone. So really, you're taking negative 15 and dividing it by what? Negative 3, right? And I keep erasing the top of that. So negative 15 divided by negative 3 is 5. So 0, 5 there is your y-intercept. Next problem. X-intercept, the y is 0. Y-intercept, the x is 0. If y is 0, remember this is gone, so you're left with x equals 8. You could even just write 8. But if you don't, 8 divided by what? What's right here? 1. So 8 divided by 1 is 8 over here. If x is 0, that's gone. Just don't forget about this negative, right? So then we have 8 divided by negative 4, which is negative 2. And that takes care of my y-intercept. Next problem, same exact thing. Y is 0 for the x-intercept, x is 0 for the y-intercept. If y is 0, you're dividing negative 24 divided by 3, which is negative 8 indeed. Likewise, if I find in the y-intercept and x is 0, this term has gone to 0, right? Instead of xing it out, I should have been doing this. I should have said this thing goes to 0, right? So if 4y equals negative 24, divide by 4. And I get y equals what? Negative 24 over 4, I get negative 6. So those are my x and y intercepts. Now the next three problems are literally solved by inspection. You see them, write them down as quickly as you can and move on, but be careful. The two major things here, it's y equals mx plus b, which means whatever sign is before the last number goes with b. So if it's negative, don't forget it. And with mx, x is not part of m or the slope. So in this first one, m is just negative 13. There is no x there. If you put an x in that box, it's wrong. If you leave the negative off, it's wrong. And then b is the other number here, 67 in this case, and it is positive. No need to write the plus there. It's understood if you just write the number down. But when you have it after this right here, you've got to put the plus here because it comes after another term. So then what is m on the next one? 11 over 20. It's the thing right here. Thing times x right there. And then the other thing is this, and it is what? Negative 99 for b. So m here is negative 1/4. Again, the thing times x. And then over here, the thing by itself is what? 5/8. And again here, even as you watch this, if you watch this, you need to write this down every time we do one of these. The slope formula is y2 minus y1 over x2 minus x1. And remember, it doesn't matter if you put y2 or y1. It doesn't even matter how you label these points as long as you call the first part of it x and the second part of it y. And if this is top one's x1, it's y1. If it's x2, it's y2. This is x2, y2. The 1s and 2s go together, but x is first and y is second. So if I label it this way, the slope is then 0 minus 4 over 3 minus, if I put negative 2, minus a negative is really what? Positive, so that's plus 2. But I did it backwards, so let me fix that. If I start with 0, I got to start with negative 2 and go to the 3, right? So I started with the wrong number. Got in a hurry. Negative 2 minus 3. 0 minus 4, negative 2 minus 3. I hope a lot of y'all during that, when I wrote 3 minus a negative 2, were screaming at the screen. You're doing it backwards. All right? So then this is going to be what? Negative 4 over negative 5. And again, what is a negative over a negative? It's a positive. So then that's going to be the slope m equals 4/5. 4/5. So we're going to have the same thing here. We have x1, y1. That doesn't look like a 1, so we'll fix that. x2, y2. And then m equals y2 minus y1 over x2 minus x1. So m equals 3 minus 5, the way I have it labeled, over negative 2. And now this is minus a negative 2, which is plus 2. All right, the thing I messed up on the last one got right this time, hopefully. So this is going to be what? Not hopefully, I got it right. M equals negative 2 over 0, which is, remember, if it's over 0, that is undefined. It's when 0 is on the top that it's 0. So this is undefined. Here, x1, y1, x2, y2. The slope is y2 minus y1, x2 minus x1. So the slope is 6 minus 6 over 2 minus negative 1 is plus 1. 6 minus 6 is 0. And 2 plus 1 is 3. This time 0 is up top in the numerator, so m equals 0. The slope here is 0. So x1, y1, x2, y2. The slope m equals y2 minus y1 over x2 minus x1. I made that a little long, so I'll fix it. So y2 here is what? 7. And then minus a negative 5 is plus 5 over, if I start with 7, I got to start with 2, right? Messed that up on the first one over there, and like I said, I hope you were screaming at the screen before I fixed it. All right, so then that's going to be 7 plus 5 is 12. And 2 minus 4 is a negative 2. Positive over a negative is negative. And 12 over 2 is 6. So my slope here is negative 6. So we're going to put negative 6 into the answer box. Then we're going to graph these 3 lines and then talk about the equation of the last 2. So if we graph this first one, this is in what we call standard form, ax plus by equals c. So again, to do this, x-intercept and the y-intercept will be the best way to do this. Oh, it's messing stuff up. So I'm going to have to do this real quick just to keep it from doing that. All right. Fix one of the quirks in it. Y is 0 for the x-intercept. X is 0 for the y-intercept. So again, if y is 0, that's gone. So then we have what? 3x is negative 12. So we're dividing negative 12 by 3 and get negative 4. And on the x-axis, negative 4 is to the left. We only go left and right when we find the actual x-intercept like this. We will not do that on the mx plus b ones, which are the other 2 graphing problems here. We will always go up and down for b because it's a y-intercept. Here, the y-intercept is when x is 0. So that's gone. So really, we're dividing negative 12 by what? By negative 4, which is a positive 3, and that is up 3 units here on the y-axis. And we have our line goes through it. And what are we going to put on the end of our line? Arrows, because Mr. Guest said he was going to count off if we didn't, because arrows are infinite. Arrows imply it goes on forever, and lines are infinite. They do go on forever. So without the arrows, you will miss points because they need to be there to say that that line keeps going on and on and on and on and on. So now the next one's in a different form. It's y equals mx plus b. So the best way to graph this is to find m and b. B is 2, m is negative 3. That's just like what we did on these problems right here, right? Find m and b. The one we just graphed was just like these 3, right? The first one we graphed on the next page. So here we always start with this. And remember, the b is the y-intercept. That's going to be up 2 because it's always up or down. So up 2 is right here. And then my slope, I'm going to think about it as a fraction, negative 3 over 1. I'm going to rise up 3 and go left 1 because it's negative. But remember, that's the same thing as down 3. That's when I took my negative, and then I right 1 because I took my negative there. So this is or. One of these or the other one. So I'm going to go up 3 and left 1. 1, 2, 3 and left 1. Or I'm going to go 1, 2, 3 and right 1. And there's a point there, okay? But those are all on the same line. Now, that line's not perfect, but again, good close approximation to a straight line. We don't want a big curve like that. That's not a straight line. So then here, this one is M is 7/3. B is -4. Again, we start here. And this time, this is down, right? It's always up or down because it's the y-axis, y-intercept. So it's on the y-axis. So down 4. And from that point, I'm going to rise up 7 and go right 3 because it's positive. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. It goes over here. So let me erase those. And it was right here. 1, 2, 3, 4, 5, 6, 7. Just making sure I'm going back to the right spot. And then extend my line through both points. Put arrows on the end. So this one is perpendicular to this line right here. So the first thing I need to do is get the slope of this line. This is in mx plus b form, right? So what is m? We already found it. We know how to find that. M of this line is -1/3. But wait a minute. Again, perpendicular, which means I want the perpendicular slope. That's all that this symbol is done that, right? Those are the same, right, instead of writing the whole word out. So the perpendicular slope, remember you flip 3/1, which is, and you take the negative and make it positive. So it's +3, and that is the slope we use. Then the y-intercept of -2 says b is -2. All right? So y equals mx plus b. This goes in here. That goes there. So y equals 3x, and then plus a -2 is -2, right? Y equals 3x minus 2. Here we have parallel to what? I'm going to change the colors, try to be the Skittles taste the rainbow problem for the day. This line, this is in the form ax plus by equals c. If somebody remembers what this is, what is the slope in this form? That's right, it's -a over b. So I need to label what my a and b are. Now remember, this is capital B and the y-intercept is a little b. So this is, wait, I don't want m yet. Capital A is what? 4. And then what is capital B? -2. So now my slope, m, is 4 over -2. Oh, wait a minute. What did I leave off? My negative, and I want to write it a little better. So my slope is -4 over -2, right? Negative a over b. A negative and a negative give you a positive. So let's go ahead and change that. Let's go ahead and make it a positive. So this is m equals positive, and 4 divided by 2, isn't that 2? So then this is going to be a +2 for my slope. And again, this here tells me what? That tells me that b is 7. So then I want to use my formula of y equals mx plus b. And when I do that, this is going to be y equals, I want to take this m and plug in here, this b right here, so it's going to be 2x plus 7. So then I'm going to circle that answer, and I'm going to put it in here, y equals 2x plus 7. 2x plus 7. So that is our review for Test 1, Intermediate Algebra. Good luck.